Hi friends, you're welcome. So we've looked at the characteristics of isoquants. So these are figures demonstrating the characteristics of an isoquant. They are everywhere dense. It is convex to the origin. Isoquants do not cross each other or do not intersect each other. And we also mentioned that higher levels of isoquants represents higher quantities of output. So we've looked at the characteristics. We will then move on to the production process. We have different types of methods of production. We have the capital intensive method of production and we have the labor intensive method of production. Capital intensive method of production is basically employing more capital and less labor in the production process, whilst labor intensive method of production is employing more labor with less capital in the production process. Okay, so we have different time periods in production as well. We want to look at two basic time periods. We have the short run production period. In the short run, some inputs are fixed in quantity whilst others are variable. Like land, in the short run we assume that you cannot buy an extra piece of land. You cannot, for capital for instance, you cannot install a new plant or build a factory. So that is a short run period of production. And we have the long run. The long run is long enough for you to be able to change even your capital and your land. In the long run you can buy more lands. In the long run you can build more factories. You can purchase more plants, install them. So in the long run all inputs are variable. Let me mention again, in the short run we have fixed inputs and we have variable inputs, but in the long run we don't have any fixed inputs. All inputs are variable. So let's move on to the short run production analysis. Measures of productivity. We have the total product, average product, marginal product. We'll look at them one after the other. So total production or total product, normally represented with TP. It is a maximum level of output that can be produced with a given amount of input. So that is a total product, and mathematically this is how it is calculated. You multiply the average product by the variable input. So the VI represents variable input, AP represents average product. Now let's look at average product also. Average product is the output produced per unit of input. Output produced per unit of input. So it is a total product divided by the variable input. And the next thing we want to look at is the marginal product or the marginal production. Marginal production is a change in total output produced by the last unit of an input. So as you added an extra input, what change did it bring to your total product? Basically that is marginal product. So the marginal product, this sign represents a change in total product divided by change in variable input. It can also be expressed as TP1 minus TP0 all over VI1 minus VI0. This side, the VI1 minus VI0, it's showing the change in variable input. So the TP1 is the current total product, the TP0 previous total product, VI1 current variable input, the VI0 previous variable input. Right, so this is a schedule or a table, a short run production table, as we can see. It's been calculated already, but let's just take some examples to see how all these figures were derived. Okay, so example 1, assuming you want to calculate the average product of the 4 variable inputs. These are 4 variable inputs. Average product, do you remember the formula? It's total product divided by the variable input. So 16 divided by 4, and that gave us this 4. Right, let's go to example 2. Example 2, we have to find the marginal product of the phi variable input. Marginal product of the phi variable input. These are phi variable input. Marginal product is the current total product minus the previous, right, divided by current variable input minus the previous. So 18 minus 16 is 2 divided by 5 minus 4, which is 1. So 2 divided by 1, and we have 2. Let's take a last example. We have to find the total product at the third variable input. Total product, if you remember, total product is average product times variable input. So the third variable input, we have our average product to be 4 and variable input to be 3. So 4 times 3 gives us 12. That is our example 3. So very simple. It's very simple to calculate total product, average product, marginal product. Let's move on to law of diminishing marginal returns, also sometimes called the law of diminishing returns. The law of diminishing returns states that as one input variable is increased, there is a point at which the marginal increase in output begins to decrease, holding all other inputs constant. Let me expound. It as well states that all other things being equal, as more and more of a variable factor or variable input is applied to a fixed quantity of inputs with a given technology, marginal product, that is the additional output, initially increases, attains a maximum, and eventually diminishes. So that is the law of diminishing marginal returns. The law of diminishing marginal returns. This is how I can explain it. Assuming you have a plant, a factory machine that produces certain tomato. Your variable input is the raw tomato. The machine is very big, so as you start and you input some few tomato, it will be producing, yes, but if you increase your tomato, your production will very well increase. But it will get to a point where the addition of the tomato maybe becomes too much for the machine, and so though initially it was increasing, it will get to a point where it might not be able to produce as you expect it to produce, because the variable input, which is the tomato, has become too much for the fixed input, which is the machine. That is where we say the law of diminishing marginal returns has set in. Okay, so at the point where the law sets in, the effectiveness of each additional input, each additional unit of input decreases. Right. Okay, so let's look at the importance of the law. Do you think it's important? Yes, it is. It is. The law of diminishing marginal returns. If you know when marginal returns sets in as a manager or as a producer, then you will note down the upper limit of your production, so that when you get to your upper limit, there is no need to add more variable factors, because your total product will start decreasing. So with that knowledge, you will always produce maximum level of output you need to produce. And the second is that the law enables producers to know how to combine variable factors with fixed factors in order to ensure efficient production. Every manager or every producer wants to be efficient in his production. Now, if you know where the law sets in, the law of diminishing marginal returns sets in, then you will know how to combine your variable factors with your fixed factors so that you attain efficiency in production. We want to pause here. We'll continue the next slide in the next lesson. Thank you.